Hello and welcome back. I'm sure you enjoyed that break. I will go and open the IDE. I already did the typing of the program, but I'll walk you through line by line so you can understand as well. So I'm just opening STM32 Cube IDE on the background, and I'll explain to you the today we are learning the I2C initialization code. So I will explain each and every line, and I'll refer that to the data sheet. I'll explain why those values are there so you will have a better understanding. And then by the demo session on the third day, I will show that in the logic analyzer through pulse view, and you'll be seeing the interface of the accelerometer. It's still loading on the background. I'm just waiting to be connected, and then I will show you the program that that I have written from scratch. Okay. So the first step, you know that you need to go File, New. You need to open a STM32 project that you have to click on this. And whenever you ask for the new project to be open, it will always take some time, and it has to link with the internal files to select the target board. At this stage, you also have to connect your target board to your computer, otherwise you'll get an error. So please do have your hardware ready to do this, otherwise you will face errors. So I have gone ahead and done all this. So I'm just taking you through in case if you have forgotten how to do it. So this is how you have to do. Once it allows us to choose the board selection, so you need to go here and then to board selector, you know which board you are using. So I'll type Nucleo F411RE and choose that board, RE, and then click next. And you got to set a name. Today we are on day 23, so I have already named as day 23, and then target project type should be started as empty and then finish, and this will bring out all these files. So since I already finished doing that, so it will generate and it will give all these files. So starting with the src, the source, you need to open the source and go to main.c. So that's our main.c program. Initially, as you remember, it comes with a few lines, so I need to delete that. And today we also going to use the STM32F4xx.h, the built-in internal header files. As if you remember on the LCD session, we went and did that path configuration and the symbol declaration. I will go through again with you. I already did, but you have to create a folder first in your desktop and name it whatever project you are working with. So in this case, we are working with A2C. So I already created a project, and then you need to create another folder called target. This is where all the ELF files will be sitting in, your .source codes and the ELF files. If you go to debug, you will see the .elf file. So this is why you need to set this target file. And also go back and copy the extracted file for using the STM32 header, built-in header, and it always comes in a zip format, so you need to extract and put it out here. So you need to do three things. You need to first go here, go to drivers, so you need to include the CMSIS driver. The device is ST because we are using ST32, so you need to use this STM32FXX. So you have to come here, include, and make sure that's the header file, STM32F411. So you go here, highlight this, copy. This is the first step. And right click on the project tree, go to properties, and go to C++ build. In this, go to settings, and then in the settings go to MCU GCC compiler. In the compiler you have to click on include paths. So I already did the two paths which I'm showing here, so you need to just press the add directory path and paste that link here. Paste that link and OK, and that will add. So likewise you need to add the core M4 as well. So the first step is done. I'll leave this open. We go back to the folder here. I'll minimize this. Yeah, okay, folder. I'll go back to the main folder, because this time we need to get the other path of the core. So it will be inside driver, and under core, click on the core, then under include CM4. So you need this file as well. So you know that it lives in this, so copy this link and come here and do the same. You need to go to C++ build settings, and then go to MCU GCC compiler, click on include paths, and go here add paths, and then paste that link here, and then hit OK, and those two links will be added. So after that you have to click apply and apply close. So that means both the paths are added. The next step is to add the symbol. After you've done that, you come here and include this statement, this line hash include. The header file should always be written in quotes, double quotes, stm32f4xx.h. So you have to include that, and simply select this, and then do a right click on this and click on open declaration. That will open the internal header file declaration. In the header file, browse or scroll all the way down and copy the STM32F411 symbol, which is this one. We already copied, that's why it's highlighting. So copy this symbol and then go back to your project tree, right click on the project name, go to properties, go to C++ build, go to settings, and then go to MCU GCC compiler. Then this time click on the preprocessor, and I already used and pasted here, that's why you can see STM32F11XE. So click on the add symbol value, and then you just paste it here, and then hit OK, and XE will be there. So this is all the three necessary steps you got to do, otherwise you'll get some build error. So it won't be able to use the internal files, internal header files. So after you done that, just click on apply close, and that will finish the job. And then you don't need the header file because we already used, so you can simply close, and then you can go and right click and build the project just to check at that stage whether you got any errors or not. Okay, so we done the first bit of including the parts and defining the symbol for the STM32. The next step is you got to define the macros that you're going to use it in your initialization program. First you need to enable the GPIO port B, because we're going to interface this to an accelerometer ADXL345. For that we are using the I2C pins SCL and SDI. For this we are using GPIO port B. So to enable the GPIO port B, this is macros are nothing but it's like a substitute. So when you write inside the function, you can use this label instead of writing 1U left shift 1, you can just write that label name. So that's what macros is. Macros is it's like a substitute. In this is a small program, so you won't see much difference, but imagine you are writing about 500 lines of code or thousands lines of code. You can't go and simply type 200 times of this, for example. So that's where the macros really come in handy. So you need to define, and to write the define, this is the example, hash define. This is how you got to write. As you know, GPIO port B is the bit 1 in the data sheet. I will also open the data sheet, just one sec. I can show where that is. I'm just opening my Microsoft Edge. Just one sec. So you need to enable bit 1 as 1. So that means enabling the bit GPIO port B. Then we're going to define that we're going to use the standard mode and the CCR, the clock control register value. The standard mode, you know, it's 100 kilohertz and the CCR value is 80. Then you need to define the maximum rise time when it is rising, so that will calculate and come as 17. Then you start off with writing the initialization function. You know how to declare a function. It has to be written with void I2C1 of init of void. Then this is the first initialization program you got to start. What I did is I opened this and then I copied all the steps from this I2C init. I copied all the 9 steps from here. I went to IDE and I pasted all the 9 steps. All the one in green that you can see, those are all the steps. You need to comment that so that you can use that for the next line. So I'll make a space so it can be easily be visible for you to see that. Okay, and okay, so once you get all of this in there, and this is pretty much the initialization program. So I'm just waiting for my browser to open. Just one sec. I'll minimize this. It's still loading on the background, but I'll go ahead and explain the program in the time being. So as you know, you got to first enable the clock access to port B. We are using port PB 8th pin and the 9th pin, that's bit 8 and bit 9. So first you need to enable that peripheral bus for that. So as you know, after this you can go and set your debug operation. As you know, right click and then go to debug as, and debug configuration, make sure you are linked to the ELF file, part 1 ELF file, and in the debugger, as you know, you need to enable the interface because we are interfacing with the built-in programmer in the STM32. That's what this step is. And you got to also enable the serial wire viewer and then apply and then debug. This will change to the debug mode, and then you can see the special function registers. So in the special function registers, the first step is you need to enable the access to port B. So that lives in the reset clock in here. So you need to enable AHB1ENR, and you need to enable this GPIO port B. So that's port A, and this bit here you need to enable that for GPIO 1. So that's this step. RCC HB1ENR, then GPIO enable. Then you need to enable the clock access to I2C1. Again, this is the I2C1 is connected on the 21 bit 21st place, so count to 21, and the 21 bit 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. This bit you have to set as 1. So this is the one that's connected to the CRCN. This bit CRCN, it's connected to the I2C1, so that's what you're connecting, that making that clock enable. Then the next step is you need to set the PB8 and PB9 as an alternate function, and that you're going to set as for what mode you're going to use it. As you know, there is 4 different modes: input mode, output mode, alternate function mode, and analog mode. So this case you're using it for output mode, so you got to set those 4 bits as 0 1 0 1 because we are using PB8 and PB9. So this is PB8 16 and 17, PB9 will be 18 and 19. I'll show you once the data sheet is open. Just give me a sec. I'll open in the other way to see if I can. It's loading on the background. Just why it's taking so long. Sheet opens and I'll refer to where they are. Okay, you need to enable that and set those bits as output mode. So that's what I written. You can't write simply as 0 here. To write the bit as 0, you need to AND that bit with the motor register, and then you got to negate that bit. So you got to do that for 16 and 17 as 0, 1, and likewise 18 and 19 as 0, 1. So these 4 bits as PB8 and PB9. Then set those to PB8 and PB9 as an open drain. So the output type of register, you got to set that bit PB8 and PB9 as output typer. And then you need to also set its internal pull-up, because we are using an open drain and you need an internal pull-up. So you have to set this as an output type, because you have to set that as 0, 1, 0, 1. So it's output drain. In this example, it's given as 1, 0, 1, 0. So to write 0, you got to AND and negate that. To write the bit as 1, you just simply OR that with the bit. And then set the alternate function for I2C. Once the data sheet opens, I'll show. As you can remember from the alternate function table, every port bit will be connected to used as a multi-purpose pin. So that pin will be connected and used as an alternate function. In this case, it's connected to alternate function register 04, and the A for 04, you have to set the bits 0100 of PB8 and PB9. So you got to set bits 3 to 0, 0 and 00. So that means bit 2 as 1, bit 7 to 4, so 4, 5, 6. The second bit and the sixth bit should be 1. So this is, I'll write it here, set bit 2 as 1 and set bit 6 as 1. This is to connect to the alternate function to use the I2C1 register, I2C1. Yeah. Then after that, you need to enter to the reset mode. To do that, to let the microcontroller know that you're using as an I2C bit, I2C mode. So you have to use control register 1 and set the 15th bit as 1. Then to come out of that, you need to just AND and negate, and that will come out of the reset state. So after the reset mode, the next step is to set the peripheral clock and set the standard mode and the CCR value. So those are the next steps. To set the peripheral clock, you need to use the control register 2, and the 4th bit you need to set that in the peripheral clock. And then the next one, you need to set the standard mode. That is, you are using the I2C1 for 100 kilohertz. And then the CCR value from the presentation, you learned that and calculated it as 80. I'll save this because I made a couple of changes. And then you need to use the CCR, the clock control register, and you're going to tell what frequency you're going to set that. So that's a standard mode. Then you need to set the rise, configure the rise mode. So use the T rise register, and this is the label that we defined here. So we're going to use that, and that's linked. And then set the peripheral, enable as 1. So this is the SD mode, rise time as 17. So we include it here. And then set the peripheral enable I2C1, and you're setting the P as 0, because you got to do all of this when the peripheral enable is 0. And then call this function inside the main function I2C1 and init. Then you finish the program, go here, right click and build a project. This time just to check for any errors or anything else that you may have to do. So it is building 19%. Once it finishes 100%, then we would be able to see the compilation. So we got to patiently wait. It's going through. Still on 19%. It's still registering. I made sure I connected the board. Yes, it's connected. But sometimes it has to check all the internal files, so that's why it takes long time before it does all the process files. Like it has to change to, as you know, object file, and then it has to generate the .elf file, which is just did. And it's almost finished. Yeah, 98%. And this is a lovely sign, 0 errors and 0 warnings, so which is really great. And this is all for this session. So now you know how to write the program for I2C initialization. And with this I conclude here and go back to our presentation. So these are all the steps we learned to do today, and I showed you as in how it has all done before. My data sheet is not opening, so I'll show you. Okay, this is what we learned. We learned about what is the I2C and what are all the different registers that we're going to use in the different message format, that sending the address frame and the data frame and the acknowledgement bit and the read and write bit. In the next session you will be learning more function to link those address frame and data frames. And then there is another dedicated session where you will interface with the ADXL 345 and you will see the demo in the Pulse view logic analyzer. As I said, you have to also shape up your mind as well when you develop your skill. So please remember TFAR rules. TFAR is nothing but the T stands for your thoughts. So you need to have the more positive thoughts, the more anything can do attitude in it, and the thoughts will change to your feelings. And whatever positive feelings you will have that positive energy in you, and those positive feelings will turn to positive action takings. So A stands for action. So all these three, the actions will take you to have the results that you are after. That means your positive results. So always stay positive and think positive, and immediately your brain will be thinking only the positive vibes and positive modes. And to be really successful, put far. So that's what for positive transform that, and then through the feelings, through the actions, you get the end result. So PT far, you have to remember that. And please do remember to do your mindset involvement. So write your top 10 goals and write top 10 ideas to achieve those goals. Please spend at least 30 minutes to do this exercise, and also please spend another 15 minutes to meditate or pray, and use 10 minutes to actually visualize for achieving that goals, and 10 minutes to work out your daily plan activities, and 2 hours will get for your learning, get 2 points. Please do post all your achievements in this group, and this will really help each other to lift each other up, and we will also be able to learn from each other. Not only that, there is combo internships coming your way. I don't want to include everything under one course, so I divided into 3 different courses. We are in the advanced. Please do purchase all the 3, so you will get the whole Cortex M4 series. And then also these are all the courses that's coming your way. You will be the first person to know once they are ready, so that you can also update your skills on this area. I take this opportunity to thank you, each and every one of you, to go through with me, and for all your patience to learn about the I2C initialization. This is Arul Anbukarasu. I am signing off on behalf of A2Digi. Huru for now. I'll catch you in the next session. Until then, take care Bye for now.